I would like to give you an overview of cannabinoid research. We have been involved in it for the last 50, 55 years. Allow me to start by a poem by Rainer Maria Rilke, written about 120 years ago. And he said, "I live my life in widening circles that reach out across the world. I may not complete the last one, but I give myself to it." Well, it is as if, in some way, he's describing what's going on with the cannabinoids. They started with a small circle and expanded, and the expansion is going on and on and on. When we started work many years ago, there was essentially no interest in cannabinoid research, the effects of cannabinoids. As a matter of fact, when I asked for a grant, I was told by NIH, when you have something more relevant to the US, contact us. Cannabis is not of interest. It's used sometimes in Mexico, but not in the US. Well, that changed quite fast. And today there is a huge interest in cannabis. As a matter of fact, the journal Nature had 4 scientific reviews on this topic. And here is one of them, which I wrote, and it shows the brain and the cannabis growing out of the brain. Now, why is this change? Why has this happened? Well, it seems that cannabinoids, or the endogenous cannabinoids, and I'll be talking about them, are involved in a huge amount of diseases. As a matter of fact, 2 senior scientists at NIH recently wrote a review, and the review says modulating endocannabinoid activity is essentially involved in all human diseases. Well, even if this is 95% correct, then it is something of extreme importance, and I don't know of any other neurotransmitter that we can say that it is involved in so many diseases. Well, I'll be talking on this topic for a few moments later, but let's go back and start with 4,000 years ago, when the Assyrians actually used cannabinoids, or used cannabis, for those purposes that we use them today. They used cannabis to cause what they said the drug that takes away the mind, which is not such a bad definition actually for getting high. They used it for some diseases, apparently neurological diseases, and it seems that they used it in some of their religious rites. Well, when we started work on cannabinoids, I was surprised to find out that while morphine had been isolated from opium almost 200 years previously, and cocaine had been isolated from coca leaves during the 19th century, the active compound in cannabis had never been purified or extracted, and its structure was unknown. So we went ahead and started isolating the compounds present in cannabis, and we found about a dozen compounds, and only one of these compounds, tetrahydrocannabinol, which we isolated in pure form, I believe for the first time, turned out to be psychoactive. All the other compounds were not of major interest at that time, at least. Well, we found out that in Lebanese hashish, which we received from the police and which we used for many years, contains 2 major constituents, cannabidiol and tetrahydrocannabinol, THC. While THC, as I said, is psychoactive, cannabidiol is not. It has nothing to do with a well-known cannabis-like activity, but it is a major drug, and many of the diseases that are being treated today with cannabis are actually affected by cannabidiol and much less than by THC. So we went ahead looking for the activities of these compounds, and one of the first activities we looked at was epilepsy. This was done in collaboration with a group in South America, and we looked first in mice, and then when we had enough data we went to humans, and we found that in a group of 15 patients, half of them were placebos, didn't get any material, and half of them got CBD at high doses. Of those 8 patients that got CBD, 4 did not have any attacks, or essentially no attacks. 3 had many less attacks, and 1 was not affected at all. So unfortunately, these results were not picked up by the neurologists for many years, and only in the last decade have children with epilepsy being given cannabis with high doses of cannabidiol, and a lot of them are being, can I say, even saved by using this particular type of cannabis. Well, another group of diseases that's being affected by cannabidiol is graft versus host disease. Unfortunately, in many cancer diseases, there should be a bone marrow transplant. Now, the body doesn't like it. When a bone marrow transplant is done, the body attacks the new bone marrow attacks the body, and the patient is sick, at times very sick. Well, but this is a kind of autoimmune disease, namely the body attacks something within the body, and so a group at one of the hospitals here thought, on the basis of other effects which had been seen, autoimmune effects of the same type, they decided to try cannabidiol, and they gave cannabidiol to a large number of patients with that were being that had bone marrow transplantation, and indeed, in many cases, they show that these patients do not develop the graft versus host disease. And for example, here are some of their results. 2 and 4 grade is a low grade disease, and while about 50% of patients that do not get cannabidiol have graft versus host disease in a little bit of a mild form, only a small number, only 12% of those that got cannabidiol were affected. Those that had a very serious graft versus host disease, which are about 10%, only 5% got the disease. So here we have something of a clinical value of, and at the moment this research is going on, and it is going on very successfully, and I sincerely believe that within a few years cannabidiol will become the central drug, the major drug in graft versus host disease. Now, diabetes type 1, again, is an autoimmune disease, namely the body attacks, for reasons that we do not know, attacks the cells that produce insulin. And this happens particularly in children. It is known as pediatric diabetes, and new drugs are definitely needed for that kind of disease. And we tried in mice, unfortunately, only we have not been able to get into humans yet. We found that in mice that have that all of them develop diabetes type 1, if we give them cannabidiol, we can reduce the number of mice that get diabetes type 1 to about 30%. If you look at the slide, you can see that the cells that produce insulin, and you can see that on the last part of the slide, the percent of the cells that produce insulin and are partially destroyed, the number is huge. 77% of the cells are being attacked and are not intact anymore. Those that got cannabidiol, only 7, 8, 10% got the cells were attacked. So here we have a very promising situation for a disease that is not well treated nowadays. These are some of the diseases that cannabidiol can be used for. But cannabidiol has to be used in a huge number of, a huge amount of material. In another field, in schizophrenia, patients were given 700 to 800 milligrams in order to get good results. And as it happens with many other drugs, one has to develop derivatives which are can be used at lower levels. And indeed, we recently reported that if we take cannabidiol and make a derivative in which there is a fluorine atom on the molecule, the level, the amount of material needed is much lower. So I hope that within a few years we shall have both cannabidiol and fluorocannabidiol on the market against many of the autoimmune diseases and quite a few others. Now, for many years after the chemistry of cannabinoids became known, we learned about the biochemistry, the pharmacology, as I mentioned, a few clinical effects. One thing that we didn't know was what is the mechanism of cannabis action, whether it's THC or CBD, but particularly THC. What is the mechanism? It was thought previously that the mechanism is non-specific, whatever that means. Well, non-specific means that we cannot really find any well-established mechanism. Well, this is how does one look for non-specific mechanism? If we have a molecule that can exist in two types, if you wish, mirror images of each other, a non-specific mode of action, both molecules will act. For a specific mode of action, only one of them will act. Well, we found that indeed only the natural cannabidiol or the natural THC work. The mirror image does not. So we established that there will be some specific mechanism, and indeed within a few years, Alan Howlett in the US found a receptor. The receptor was found in the brain, and it is widely spread in the brain, probably one of the receptors that found in the highest amounts in the brain. But receptors don't exist because there is a plant out there. Receptors exist because animals, we produce compounds that affect these receptors. So we went ahead looking for the compounds in our body, endogenous compounds, which will affect these receptors. And after work for quite a few years with colleagues that came from the state and a colleague that came from the Czech state, we found a compound which we called anandamide, and we found also another compound which we called a 2-AG. These compounds are found throughout the body, and particularly in the brain, and particularly in those areas of the brain which you can see on the slide where the receptor is found. And these two compounds have a completely different structure than the natural plant product, but they have the same activity more or less, and they also, like the plant product, do not dissolve in water, they dissolve only in lipids, and they act in the same way with one difference. They are formed when needed, they're broken when needed, but the plant material stays for a longer period of time. So there has been a huge, huge amount of work, and you call this particular research as the second phase of cannabinoid research. The first phase is the work on the plant cannabinoids. The second phase is the work on the endogenous cannabinoids. And I will not go into biochemistry, of course, except one thing. Why are these compounds, whether it is the plant compound or whether these are the compounds that we produce, the endogenous cannabinoids, effective in so many biological things? Why? Or in so many diseases? Well, one thing they do is they regulate the activities of many other neurotransmitters. A nerve is not a string going from one place to another. Nerves in the body are broken down, and that's called a synapse. And the synapse is in our body because in this way the body can regulate nerve activity. Now the synapse, there are chemicals which move from one side to the synapse to another. These are the neuro compounds that are neurotransmitters. Well, the endogenous cannabinoids regulate the release of these compounds. They sit on the part of the synapse, the postsynapse called. When needed, they move to the presynapse, and there they activate a receptor and affect the production or the release of these neurotransmitters. The bottom line is the endogenous cannabinoids regulate to a large extent what's going on in the brain, what's going on with neurotransmitters. So to make a long story short, the endogenous cannabinoid system today is known to have two receptors. The CB1 receptor is the one when stimulated causes the activity, the cannabinoid activity. The second one is a protective, is of a protective nature, and it has nothing to do with the psychoactivity of cannabis. Then, of course, there are the two endogenous compounds, anandamide and 2-AG. I talked about them. There are, of course, the enzymes, those enzymes that form the endogenous compounds and those enzymes that break them down. And by playing with these enzymes, we can actually enhance the activity, enhance the amount of the endogenous compounds, or we can even leave them for a much longer time in the body by blocking the enzymes that break them down. And of course there is the THC and cannabidiol. So there is a huge amount of work going on, and these compounds are known now to affect, as I said previously, a long list of things that are going on in our body. And if you can look at the list that I have on this slide, it starts with anxiety and blood pressure and the digestive system, etc., 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 and it goes down to stress. And if I have a full list, I'll probably need another 2 or 3 slides. Now, let me tell you some of the activity of the endogenous compounds. One of the activities of the endogenous compounds is a protective activity in the brain. Together with a colleague of mine, Professor Esti Shohami, we looked at what happens to the brain when it has been slightly damaged, brain of mice. And we found that one of the endogenous compounds, the 2-AG, and it is in the red on the slide you have, the 2-AG goes up about 10 times after even a slight damage to the brain. Now, is that because the brain has been damaged and it doesn't do what it should do, or is that some kind of a protective mechanism? So we synthesized 2-AG and gave it to mice that had undergone closed head injury. And we found that indeed those mice that received cannabidiol had much less damage in the brain. The damage can be seen in the white part in the slide in the brain. The damage goes about 50% less. So here we have a typical effect of the endogenous cannabinoids, neuroprotection. And we and many other groups looked at a huge number of effects, but some of them, the effects were not as strong as we expected. For example, on brain injury, there is vasoconstriction of the blood vessels. And endogenous cannabinoids do affect vasoconstriction, and vasoconstriction is part of the damage, but the body seems to have something that affects much more that the brain. So we started looking for maybe we have additional compounds, additional endocannabinoids, and indeed we found that there are compounds that are closely related to the endocannabinoids, but do not act as endocannabinoids. They do not bind to the receptor. They do not have many other activities, but they definitely act on the vasoconstriction. And one compound of this type, as you can see on the slide, it is closely related to the other compound, but it doesn't bind to the receptor. It is formed from a fatty acid bound to an amino acid. Amino acid in this case is serine, and this particular compound, we see it, and it has been accepted as a endocannabinoid-like compound found in the body. And today we know that there is a huge number of compounds of that type, about 120 compounds of that type, and we know very little about the activities of these compounds. For example, in this case, we know as I spoke about ARA as arachidonylserine, it does not bind to the receptor, but its activity can be blocked by an antagonist to the receptor. Very strange, because how can a compound which does not bind to the receptor can be blocked by an antagonist? We don't know why this happens. But on the other hand, that's what it does. So there is something that we have to look at. In a completely different area, bone remodeling. We were surprised to see that osteoporosis can be affected by compounds of this type. This has a long history. It is known in the Middle East that there is less osteoporosis than in Northern Europe. And it is believed that this happens because people in the Middle East use more olive oil than others. So we looked at the presence of compounds of this type in olive oil, and we didn't find anything. But then we decided maybe one of the constituents of olive oil, in this case a compound called oleic acid, is metabolized in the body to a compound that's very active. And so we prepared a few more metabolites, new compounds, and yes, we found that a compound closely related to anandamide, and you can see in the slide the structure of anandamide and the structure of this metabolite of oleic acid, oleilserine, which does not bind to the receptor, does not cause the effects of anandamide, but is a very potent anti-osteoporotic compound. If we have mice and we cause osteoporosis in mice, and there are ways of doing it, and bones are affected, and you can see in the middle, the red is the affected bones. If we start giving these mice this particular cannabinoid-like compound formed in the body, formed in the bones, we can see that the bones start recovering. They start regrowing ahead. So here we have a huge number of biological, physiological effects that have to be looked at, because we know, as I've mentioned previously, that there are almost 120 compounds of this type. And we have looked at these two, and there are many others that have to be evaluated. So let me try to summarize what I have been talking about. First, the endocannabinoids are involved in a huge number of biological effects, and we can expect to have to see many others as many groups are working in the field. We know that cannabidiol is an important compound, although it doesn't cause the well-known effects of cannabis. And there is the third group of compounds that people are just looking into now, and these are anandamide-like compounds, which are like anandamide, formed from a fatty acid bound to an amino acid or a derivative of amino acid, and these compounds seem to be effective in a huge number of physiological processes. And I sincerely hope that within the next 3 years we shall see drugs, particularly of this third type of endocannabinoid-like compounds, and of compounds that act specifically on the CB2 system, which has no marijuana-like effects. I would like to thank many of my collaborators. This is a list of some of my collaborators in Israel. Some of them are my students, some of them are colleagues in departments, and I want to say thanks to many other colleagues abroad. You can see on the slide some of my collaborators abroad, and you can see that they stretch from the UK in Aberdeen, my good friend Pertwee, through the Czech state and Greece and Richmond in the US, and even Siberia. I visited all these places except Siberia. It's too cold for me. Thank you.